This video will explain different types of study designs. The purpose of this is to better understand how science is done. First thing we're going to talk a little bit about is the difference between cause, risk factor, and a confounding factor, and then we'll move on to different study designs. We can say a cause is any factor that can directly lead to a disease. So for example, microorganisms can cause the flu. The HIV virus causes you to get HIV. Chemical or radiations may cause cell damage, causing cancer. So for example, asbestos exposure can lead to damage to the lung tissue, which can cause lung cancer. The risk factor is a little different. It can be a trait, a behavior, or condition which can increase the likelihood of a disease, but on its own is insufficient to cause the disease. So for example, if we're exposed to environmental tobacco smoke, we are more likely to suffer some sort of cardiovascular disease, but potentially on its own, it does not necessarily cause cardiovascular disease. So just because you're exposed to it doesn't mean you're going to have a heart attack, but the more you're exposed to it, the more likely you are to develop cardiovascular disease. We can categorize risk factors into modifiable and non-modifiable. So for example, classic example of modifiable is something like exercise. These are things we can change. Our diet, exercise, whether we smoke or not. And there's risk factors that we can't change, like our age, our genetic history, our background, etc. Third type of factor that I'd like to talk about are confounding factors. And these are factors that appear to be associated with the disease, but in fact are not actually causal. So for example, we can often find an association between coffee drinking and lung cancer. However, coffee drinking does not cause lung cancer. There's actually another correlation between people who drink a lot of coffee actually smoke a lot of cigarettes. And so it's the chemicals in cigarettes that cause lung cancer, but we can often make a mistake by saying that correlation is causation. You've probably heard that before. That's what we're talking about. So coffee drinking does not cause lung cancer. It's the chemicals in smoking, but they're both correlated. So let's move on to how scientists establish causes and risk factors for a particular disease. There's a bunch of different study designs. Group 1 would have not as much power to determine a causal relationship, although they give us hints to them. And these are going to include ecological studies, cross-sectional studies, and case control studies. And the second group have a much stronger study design and can provide some evidence for causal relationship. So these would include longitudinal studies, which are often called cohort studies, and intervention studies, or also known as randomized controlled trials. So the first we're going to talk about are group 1 of studies. These are not as powerful. They can suggest associations, but they don't suggest causality necessarily. First and least powerful is what we call ecological study designs. And this is where we can compare diseases in one community versus another to come up with some inferences. So for example, in certain communities there may be fluoride in the water, in other communities there aren't. And early on in health promotion they discovered that the folks who lived in communities with high levels of fluoride in the water had less dental decay. Subsequent studies went on to look at the effect of taking fluoride on dental health, and sure enough, it turned out to be that there was some cause and effect. Second type of study here is what we call a cross-sectional study, and this is where we take a survey of certain people in the population at a single point in time. So for example, you might have a large group of people and you may get data from just a small proportion of those people and draw some inferences. Information from these surveys could show that people have high levels of disease. They might also share certain other characteristics. For example, they may all have a high sodium diet. that could lead to hypertension. Third type of study in this group are called case control studies. And these are studies that compare a sample of people with a disease or condition with a control sample of people without the disease. So you may have a group of people who all have a disease, and you would find their matching controls who have similar characteristics to the people who are the cases. They would be matched based on age, gender, employment, socioeconomic status, etc., so that they were as closely matched as possible. The only difference being one group has the disease. The odds ratio would be the probability that the people with the disease are more likely to have a particular characteristic or exposure compared with the control. So, for example, we might find out from this that all the cases have a particular characteristic here, a green face, and the controls do not. And so we can draw some inference there. This is particularly good for looking at rare diseases or potential genetic mutations. And this is where some of the really new innovative research for genetic causes of diseases has come from. Moving into our second group of studies, they are much stronger in terms of study design, and therefore we can draw some inferences for causality. So the first type is called a cohort study, also called a prospective or a longitudinal study, depending on who you're talking to. And this is where you take a group of people and follow them over their entire life or for a certain amount of time. You take multiple measurements over that time. So the difference between the cross-sectional and longitudinal is that the cross-sectional, the population is measured once, and the longitudinal, that population would be measured multiple times. As an example, we may take a group of people and study them in the 1970s and look at a bunch of different dimensions. And then we find them again in the 1980s and measure exactly those same dimensions again. We then find them in the 1990s and measure them again on the same criteria. The advantage to this study is that it allows us to measure relative risk and provides powerful evidence for causal links. The unfortunate thing about this type of study is that it can be very expensive in terms of both time and effort for follow-up. It may not be suitable for rare diseases because of the large sample sizes needed to include enough cases. So here's an example. You might find a sample of people and determine the folks who were exposed to something and the ones who weren't. So for example, those who got exposed to asbestos in their workplace versus those who aren't. And you look at the number of people who develop the disease, such as lung cancer, and those who don't. In order to draw some causal links, that we would see that a greater number of people in the exposed condition would have developed lung cancer than the non-exposed. This is how the first evidence for the correlation between smoking cigarettes and lung cancer. So this was done in British doctors, about 40,000 of them in the 1950s. And they looked at the death rate compared to number of cigarettes smoked a day. And you can see a very strong association here based on the people who were exposed to tobacco smoke versus those who weren't. The fifth type of study we're going to talk about is the most powerful. This is considered the gold standard. It's referred to as either an intervention study or a randomized controlled trial. This would involve exposing a group of people to a particular intervention, diet, lifestyle change, something or other, and then measuring what happens as a result. You would allow a certain amount of time for follow-up to find out if the intervention actually offers significant benefits compared to that who did not receive a similar intervention. The intervention and control groups are selected at random, and it very much is considered a gold standard. So for example, you might have a group of people where you do pre-testing on them. Maybe you might measure their exercise adherence. You would then randomly assign them to one of two conditions here, condition 1 or condition 2. You can then measure these same people again in post-testing, and you'll be able to compare the people who are exposed to condition 1 versus condition 2 and see who did better. So the major difference between a cohort study and an intervention study is that the cohort study, people are self-selecting into different criteria. And in the intervention study, it's the researchers who are assigning people. You can imagine, for certain things that are potentially dangerous to people's health, that we wouldn't be able to use an intervention study. So for example, if we wanted to test the effects of smoking on lung health, we'd have to use a cohort study because we wouldn't want to cause harm to our participants by assigning them to start smoking.